Hey, what's up, guys? Chung here again. And then this time, I'd like to discuss about this LeetCode problem here, number 474, ones and zeros. It's a medium level. So, okay, let's take a look at the description. So you're given an array, strings, a string of array of strings, with strings, and each of the strings only consists of only either zero or ones. Okay, for example, this one, and you're given two integers m and n. Now it asks you to find the maximum number of strings that you can form with given m and n. Each 0 and 1 can be used at most once. Basically, what it's asking you to okay, so each of the number can only be being used once, and the total 0 and 1s cannot be greater than this m and n. Yeah, I think by the time you guys see each 0 and 1 can only be used at most once, and you're given like some target, then you should you should have already realized that this is another knapsack problem, right? And to be more specific, this is a 0-1 knapsack problem because each uh, each 0 and 1s can only be used at most once. Uh, each 0 or 1s. Yeah, basically each of the strings, right? Basically, it says that each of the strings can only be used at most once, and with m and n here. So this is very similar as the very basic like knapsack 0-1 knapsack problem. The only difference here is that instead of one target, if you guys have seen my previously videos about the basic 0-1 knapsack problem, for that problem you are only having one capacity, but in this case for this problem you have two capacities. Okay, that's basically that's just make this one a 2D 0-1 knapsack problem, and other than that the rest should be the same. Still, basically, so now the problem converts to among all those strings, right? Among all those strings, uh, what's the maximum items? Basically, what's the maximum items we can pick, right? What's the maximum number of items we can pick? And assuming we can only pick each of the strings at most once, and the capacity is like the zeros cannot be greater than 5, then this m, and the ones cannot be greater than 3, right? So, and okay, so with that, all we need to do is we just need to define like a DP array here. Remember, for the 1D knapsack problem, we only need to define the capacity at 1, right? Basically, that's. But in this case, since we have two capacities, that's why we need to define a 2D array here, and it's gonna be the n plus 1 for in range m plus 1. Okay, and then the rest should be very similar, like the normal knapsack problem template. Basically, we loop through for each of the string. In this case, for each of the item, right? So in this case, it's a strings, right? And then okay, so and remember, so for the knapsack problem, for each of the item, we have the weight and the value. But for in our case, for this case we don't care about the values, right? All we care is the weight, and right. Then what's the weight for this, right? The weight will be the total number of 0 and 1s, right? So that's why I'm gonna have like zeros equals to as count zeros, right? once equals s dot count once. I mean, but I'm using two for loop here, but we can like combine this one into one for loop, but it doesn't affect our total time complexity. That's why I'm just using a built-in Python functions. Okay, right, and then uh, yeah, and other than that, remember, so for the 1D knapsack problem, we need to loop from the biggest to the smallest, right? If you guys don't know why is that, because you can maybe you can check my previous uh, videos about the knapsack problem, because well, we want to we when we calculate the current state, right? We only want to use the value from the previously, I mean, uncalculated states. That's why we have to process from the biggest one to the smallest one. And since we have already compressed the time space complexity from 4D to 2D, because if it's like we want to use the complete to the state, we will need to define like a 4D DP. Okay, but in this case, since we already compressed it, that's why we have to loop from the biggest to the smallest. Okay, and here uh, the starting point is m, right? And the ending point is gonna be the zeros. M is zeros, right? It's gonna be zeros minus one, right? Same thing for the j, right? J in range n plus ones minus one, okay? And then basically the dp, I and j, right? That's the basically that's the total, that's the max number we can get, right? The max number we can get with the uh, with the with the first with the first s strings and the with the first s strings and to the to not exceed the i's zeros and the j's ones, right? And then the max here is going to be dp I and j and dp, right? So I minus zeros, right? That's going to be the, okay, and j minus ones, okay, right? And then plus one, right? Because so and since we have 2D states here to get the previously state, right? So what's the previous state? So the current, so this one means that we're using basically we're picking, right? We're picking the current we're trying to use the current as. And once we decide to use the current as, we will be adding. So basically, we're assuming we will be having this zeros and ones, right, already. And then the previous state will be the I minus the current zeros and J minus current ones. That's why we have to limit our for loop until the zeros and ones. Otherwise, the zeros and ones will become negative, which will be the invalid state, right? And then after that, we always do a plus one, because since we already decided we use this string, that's we're assuming, okay, we are adding this one to our final result, okay, right? And in the end, we simply return the dp m and n, right? It means that after uh, looping through all the strings with the maximum m zeros and n ones, what's the maximum? Basically, that's what's the question is asking us, right? What's the maximum uh, strings we can use? Uh, yeah, okay, let's try to run it. Okay, so the test case passed, and let's try to submit it. Submit. call it pass. It's not that fast, but I think this should just work. Yeah, let me try to submit it one more time. Yeah, this time it's better. But anyway, that's not the point, right? Basically, okay, so okay, so the space and time complexity, right? So the time complexity, as you guys can see, is the length of the string, right? That's the length of the string I'm s, right, times m times n, right? That's the time complexity, and the space complexity is obviously m times n. Okay, and yeah, I mean, just re do a real quick recap here. It's every time when you guys see it's use like zero or ones, or use translates to use the one strings item once, and then you're given like a target, then it's a backpack, it's a knapsack problem. And for this problem, we have two target, right? Instead of one. So we simply adding one more dimension into our DP state. And other than that, it's the same thing. And we just need, for each of the string here, we will get the weight, right? Basically the weight for the item, and then we just loop through from the biggest to the smallest, and then we're trying to use the previous state, right? Basically the current I and j minus the weight will give us the previously state. And here in this case, we're using we're trying to get the numbers, right? It's not the values. So if you're asking if there's another like variations asking us to get, okay, what's the max value, right? And for each of the item it stands contains, but in this case this one doesn't have any value, just like the weight itself. Then we're gonna have like a value here, but right, something like this. But in this case, the string doesn't have any values. All it has is like the weight uh, will be represented by the numbers of zeros and ones, right? And then in the end, yeah, simply return this 2D, the last element of the 2D array. Cool. I think that's it for this problem, for this knapsack problem. I hope you guys maybe getting more familiar with this kind of this big category of DP problems. And yeah, thank you so much for watching the videos, and stay tuned. See you guys soon. Bye bye.